All right, so in this video, we are once again talking about how to solve matrices, but this time, or I'm sorry, solve systems with matrices, but this time we're doing it with row operations. And to start, we need to create something called an augmented matrix. So it's going to look a little bit different than last time. So let's say we've got this system down here, and I want to rewrite it as an augmented matrix. So we're not going to have any variables. We're just stripping it down to the coefficients and the constants. So each row is going to represent one of the equations. Okay, so in our first equation, we've got a coefficient of 1, -3, 1, and then we're going to have this vertical bar that separates the constants and the coefficients. So just kind of think about that vertical bar as being your equal sign. So then the constant of 6 would be over here. Okay, well, then our middle row would have a coefficient of 1. There isn't a y, so its coefficient's 0. 3, and then we've got our constant of 12. And then our last equation is 5, 1, and there's no z, so the coefficient there would be 0, constant of 1. So this is an augmented matrix, okay? Each row represents an equation. Each column represents, the coefficients of x, y, and z. And then on the other side here, we have our constants. So to be able to actually solve a system with row operations, we need it to be in the augmented matrix form. Our goal is to turn that augmented matrix into what you see right here, which is what we call reduced row echelon form. Because if we have just a 1, 0, 0 as the coefficients in our top equation, that means that the x value of our solution is equal to whatever a is. Okay? Our middle row would tell us the y value of the solution, and our third row would tell us the z value of our solution. And keep in mind, that would be if we have a 3-variable system. Okay, we're going to be working with 2-variable systems, so for us, this reduced row echelon form is only going to have 2 rows because we only have x and y. So it's going to look like this for us. Now, let's talk about what row operations actually are. Okay, they're the things that you're allowed to do between the rows and with the rows to manipulate them and turn them into this reduced row echelon form. So what we're allowed to do is switch any of the 2 rows, and honestly, we don't really do that often. Okay, but we do multiply by constants a lot. We do add rows together a lot, and we use a combination of those 2 things even more. So let's take a look at, what the row operations actually look like, and we have to be careful about writing down, what we're actually doing, like what are our steps, so that it doesn't look like a bunch of magical things happening here. Okay, so we're going to look at a 2-variable system. This is the same system we saw in our last video with the matrix equations. Okay, but this time we're doing an augmented matrix. So let's change this to an augmented matrix. Okay, I've got my constants on the right side, right here, and then on the left side we have our coefficients. Each row represents a separate equation. Okay, and our goal is to get it, I'll write it down so you can see it again. Our goal is to get it into that reduced row echelon form. We're trying to figure out, what is A, what's B, because that's going to be our x value and our y value of the solution. So, where to begin, right? That's the hard part here. You should always start by trying to find zeros first. You want to worry about the ones last. Those will be easy to find if you have your zeros. So I'm going to start by trying to make a 0 right here in my top row. To do that, my idea is, if I could make this a -2, I could add it with my bottom row, right? -2 plus 2, that'd make a 0 there. So how do we write that? Because that's a great question, right? How do we actually express this? Well, typically, you're going to see me doing it like this. Okay, I'm going to say, okay, that original augmented matrix is going to change. So I've got my arrow, right? And we're going to say how it's changing. We're saying we're going to have a new row 1 that is equal to the original row 1 times a -2 plus row 2. So let's rewrite our matrix here. Okay, notice that we're not changing anything in row 2. We're using row 2 to change row 1, but we're not actually changing row 2. So I'm just going to go ahead and copy it down. So every time we're doing something to row 1, okay, we're going to write the new number down. So row 1 is equal to the original row 1 times -2. So that'd be a -4 plus a 3. So we're going to get a -1 in row 1 in that first column. Okay. And then I move to the next column. 1 times -2 is -2 plus 2 gives us that 0 that we wanted. Okay. Then we move to the next. So 0 times -2 is 0. If I add row 2 with that, I get -2. Okay. So we got the 0 that we said we were looking for. Well, let's go ahead and let's make a 0 down here. Let's get all of our zeros before we worry about those ones. To get a 0 here, okay, I kind of notice, all right, well, if I could change row 1 so that this was really a -3, I could add those two rows together and I would get a 0 in my bottom row. So we don't actually want to change row 1. That would be kind of counterintuitive here, but we can manipulate and write an equation that will multiply row 1 by 3 so that we get that -3 we're looking for. So the only thing we're going to actually change is row 2. We're going to say our new row 2 is equal to the original row 2 plus 3 times whatever is in row 1. So again, the confusing part here is our equation makes it look like we're actually going to be changing row 1, but we're not. Okay, row 1 is still going to be -1, 0, -2. But in our calculation for the new row 2, we're going to take what was in row 2, so 3, and add 3 times row 1. So 3 plus 3 times -1 is going to give us 0, which is what our goal was. Then we're going to do 2 plus 3 times 0, so it's going to stay 0. So we just get 2. All right, then we're doing -2 plus 3 times -2. So if we do that, we really have -2 plus -6, which is going to give us a -8. And now we've got the zeros right where we want them. Okay, our goal now is going to be getting those 1s, but it's going to be pretty easy. All right, let's get a 1 in our top row here first. If I want to turn this into a 1, a positive 1, I just need to multiply by -1. So we're going to multiply row 1 by -1 to get the 1 in that upper left-hand corner. So if I multiply by -1 in my entire top row, I get +1, 0, +2. Okay, bottom row hasn't changed. So now our final step, in order to get a 1 here in our bottom row, okay, to turn a 1 or a 2 into a 1, I need to multiply by 1/2. So we're going to say row 2 is equal to 1/2 times row 2. So 0 times 1/2 is 0. 2 times 1/2 is 1. -8 times 1/2 is -4. And we have found our solution. Okay, remember, each row represents an equation. So this top row is really saying 1x plus 0y is equal to 2. Well, that tells me that x equals 2. My bottom row says 0x plus 1y equals -4, so that means y equals -4, which means the solution to my original system would be the point 2, -4. Now, I know that these row operations are confusing, and I promise you it gets better as you practice. So we will be talking about this more, okay? But you really just have to sit down, do the practice, become comfortable with what you're allowed to do when it comes to row operations before you start feeling more confident. So that is it for this video. Have a great rest of your day.